In this lesson, we are going to talk about critical points. So we're going to find critical points from this, but let's talk about what critical points are first. So critical points can help find extrema. By extrema, we mean max and mins. All right, so maximums and minimums are going to occur when our slope equation, our derivative, is equal to 0. So visually, you have a maximum when your slope is 0. You have a potential minimum can happen when your slope is 0. However, you also may get situations, which I call a chair, where your graph levels out, but it doesn't create a maximum or a minimum. So, and you're not going to know that until you kind of dig a little deeper to figure out what's going on. But initially, we're going to take our derivative, set it equal to 0, and we're really trying to figure out when we have some maximums and minimums. But this kind of a situation could happen when we have a slope of 0, but we don't have a maximum or a minimum. And then our other critical is when our slope equation does not exist. And that could be because of an asymptote, or it could also be from this. Your graph may go vertical for a second, where the graph's not broken, there's not an actual domain issue, but we have a slope that's undefined. So we have a rise, but we have a run that is 0. So that's kind of what we're looking for. And so let's do an example. So we're going to take the derivative of this, we're going to set it equal to 0, we're going to figure out our critical points. So if we do the derivative of this, a little bit. So if we do the derivative of this, we have a product rule. So we're going to do the derivative of the first times the second. So that's going to be a 2x e to the 4x squared plus 10x plus 4 plus the first times the derivative of the second. So the derivative of our second is itself, because it's an exponential, times the derivative of the exponent. So 8x plus 10. All right, so now the algebra kicks in. We got to take that and set it equal to 0 and see if we can figure out the factors to it. So here's our first piece. We have 2x e to the 4x squared plus 10x plus 4 plus, if I multiply this in, I'll get an 8x cubed plus 10x squared. So 8x cubed plus 10x squared times that exponential, e to the 4x squared plus 10x plus 4, and we're setting that equal to 0. So to solve this, they both have this e piece right here, so I can factor that off. E to the 4x squared plus 10x plus 4. And then I would be left with a 2x plus this, which is 8x cubed plus 10x squared. And that's equal to 0. So I have my factors. I'm going to set each of my factors equal to 0. So I'm going to set this exponential, 4x squared plus 10x plus 4 equal to 0. And I'm going to take this cubic, 8x cubed plus 10x squared plus 2x, and set it equal to 0. All right, so the exponential actually is never going to equal 0. There's nothing you can raise this to actually get a 0. So that's not going to get us any answers. but the cubic can equal 0. So we need to look at how we're going to solve that one. So I'll start by factoring out and 2x to every single piece. So that'll get us a 4x squared plus 5x plus 1. And then this quadratic factors further. So I can factor that into 4x and a 1, and my only choices are a 1 and a 1. I could do a 2 and a 2, but let's see if this works. So this is a 4x and this is a 1x, and if I make them both positive, they would add up to a 5x. So if I set each of these equal to 0, I would get a 0 out of that. I get a negative 1/4 out of that, and I would get a negative 1 out of that. And those are my critical numbers. Now, I don't know if they're maxes, mins, or anything special, but I do know that those would be my critical points that I would do a little bit more investigation to figure out if they're maxes or mins.